Hi students, today we will discuss about Hill's double slit experiment. I will give a few important things about Hill's double slit experiment here today in this class. And what is the Hill's double slit experiment? The Hill's double slit experiment is explain the interference pattern of in the optics. It will explain the interference phenomenon. And in Hill's double slit experiment, we discuss mainly what is the fluid width. Yeah. Since double slit experiment means since it is explained by the scientist Einstein. And we have the two slits. The first one, and this is two. These are the two slits we have. And we have one screen here. The screen distance is capital D. And the slit distance is small d. Now from the primary source, if you take this rows from these two, and points here, between this one wave suppose, and this is our one more wave we have. And these two are interference at this. And this point rho. Okay. This distance will be equals y. I will explain a few things about this experiment, how the questions will ask in this particular examination point of view only, not detailed explanation. So first we should know about what is fringe width, how the bright fringes will form, how the dark fringes will form. Here we should discuss about. First, bright fringe means it will use a constructive interference. Constructive interference means, and from the waves, we know the crust and trough will come. The first wave crust is overlapping with the second wave crust. Another way, first wave trough is overlapping with the second wave trough. It's like quantities or interference each other. Then we are getting the consecutive interference. Consecutive interference means the intensity of the light is increases. And when the first wave crust is overlapping with the second wave trough, or otherwise second wave trough is overlapping with the crust is overlapping with the first wave trough. Means unlike quantities are superimposed each other. Then what happens? The intensity of the light will be reduces. The intensity of the light interference that we call as destructive interference. In destructive interference, what happens means the intensity of the light will reduces. Now here they ask what is the fringe width and what is the path difference means. Here path difference we have. This we call as path difference delta x. Path difference we can write here S2P minus S1P. If this is a T, it's make an angle theta means this path difference is equals to D sin theta. So from the diagram, the path difference we can write S2P minus S1P equals to D sin theta. And this is the basic formula you should know while doing the problems also. Okay. And D sin theta is equals to, for consecutive interference, the path difference is equals to, from the diagram it's for bright fringes, for the bright fringes, the path difference should be equals to n times of lambda. Now equating these two, T sin theta is equals to n lambda. So from the diagram, if you want to just make an angle theta, sin theta is equals to, you can write, when theta is very small, you can write D into opposite side by this y n by d, that equals to n lambda. So from this, we want yn is equals to and lambda capital D by small d. And lambda d and small d. So it will give nth bright fringe. If you take yn is the position of nth maximum. Position of nth maximum. One thing is the position of nth maximum. If you take n equals to 1, you will get then y1 that is equals to lambda capital D by small d. This we called as first bright, and n equals to 2 means y2 equals to 2 lambda capital D by small d. This we called as second bright. This is first bright and second bright we have. First bright and second bright. Now, if you see the difference between these two, second bright and the first bright, y2 minus y1 if you do, this is 2 lambda capital D by small d minus lambda d by small d is equals to, we have lambda d by small d. The difference between these two we called as fringe width. Fringe width formula beta equals to lambda capital D by small d. Okay. This is about bright fringe. And now coming to see that first bright and second bright. Now see here. So we have first one is equals to lambda capital D by small d. Y2 equals to 2 lambda capital D by small d. Y3 is equals to 3 lambda capital D by small d. Just now we derived beta equals to lambda capital D by small d. Beta equals to lambda capital D by small d. Now, if you take the difference, this is nothing but first bright is nothing but 1 beta. Second bright we called as 2 beta. Third bright we called as 3 beta. Okay. So beta, whenever they ask 10th beta, 10th bright, so we can write directly 10 times of beta. Okay. And similarly, if you take what is the intensity of the light when this is in the constructive interference? What is the formula for the intensity of the light if they ask? We know the formula I equals to 4 I naught cos square pi by 2. Cos square pi by 2. So cos square pi by 2 means we want the maximum intensity, means cos function should be maximum. Means this cos pi by 2. The maximum value of the cos is equals to 1. This is equals to 1 means it becomes only 0 degrees pi. Okay. So we can write then the pi value is equals to pi by 2 if you take 0 plus or minus 5 plus or minus 2 pi, like it will come. So the path difference is then I maxima for the consecutive interference, if they ask I maxima, that is equals to 4 times pi naught. This is for the bright fringes. Okay. Now coming to the dark fringes. So dark fringes means first one crust is overlapping with the second wave trough, or otherwise first trough is overlapping with the second crust. Means both are in the outer phase. Then what happens means the intensity of the light will be reduced. Intensity of the light reduces means that we call as diffractive interference. Diffractive interference means the intensity of the light will be slightly decreases. Okay, so that's why we call it as a dark fringe. So dark fringes means the path difference is how much? Means We have the condition for this destructive interference, the path difference delta x equals to, from the diagram we have S2p minus S1p, that is equals to t sine theta. And in class 11th in the chapter waves, we discuss about constructive and destructive interference of the principle of superposition. When the intensity is increases, when the intensity decreases, what is the condition for the maximum intensity, and what is the condition for the minimum intensity and all. So there we have the path difference is equals to 2n minus 1 into lambda by 2. This is. Now, if you equate in these two, the sine theta, already we discussed about y by capital D equals to 2n minus 1 into lambda by 2. So we want yn again here. Yn is equals to 2n minus 1 into lambda capital D by 2 times of small d. Lambda capital D 2n minus 1 by 2 become. So this is the dark fringe. Now see, we know the formula of the dark fringe. So lambda capital D by small d into 2n minus 1 by 2. So lambda d by d is nothing but we know that beta. This we can replace beta into 2n minus 1 by 2. Now, if n equals to 1, then n1 equals to 2n minus 1 means becomes beta by 2. If n equals to 2, that we can replace y2, that is beta into 2 3 is 6, 6 minus 1. Sorry, 2 2 is 4, 4 minus 1, 3. It becomes 3 by 2. 3 by 2 means it becomes 1.5 times of beta. This is 0.5 times of beta. Similarly, if you take n equals to 3, we have 3 is equals to beta into 6 minus 1. If you 6 minus 1, it becomes 5 by 2. This is becomes 2.5 times of beta. Now see here, see y1, y2, y3, if you see, if they ask 1, it is 0.5. If they ask, it is 1.5. If they ask 3, this becomes 2.5. Then suppose if they ask 40th dark, 40 previous number, preceding number is 39. So you will get 39.5. So if you, for example, take an equals to 4, and 4 is equals to 7 by 2, it becomes 3.5 times of beta. Now, if you take the difference of these two, it is beta. So if you take this difference, these two beta, this is beta. So fringe width, we can write, it is nothing but the separation between two successive dark fringes or bright fringes, we call it as fringe width. And here we discuss about the intensity of the light. We have the formula I equals to 4 I naught cos square pi by 2. So for the maximum intensity, so we discuss about the minimum intensity. For minimum intensity, we can write cos pi by 2 should be equals to 0. Should be equals to 0 means this pi by 2 equals to plus or minus pi by 2. Pi by 2 5 pi by 2 extract will come. Then pi is equals to how much? 5 plus or minus 5, 3, 5, 4, 5. Sorry, not 4, 5, 5, 12, 9. So this we can written as odd numbers 2 n minus 1 times 5. So then the minimum value was to 0. I minimum is equals to 0. Okay. So we have the fringe width. Fringe width formula beta is equals to lambda d by capital U. Okay. Then the fringe width if you take beta equals to lambda by 2. Now after that for the consecutive interference we want what is the condition for the amplitudes and intensities also. Consecutive interference means amplitude is maximum. A max we can write A1 plus A2. Maximum intensity. And we know the relation between amplitude and intensity. Amplitude is directly proportional to the intensity square. We can use that condition, so we can write I max equals to root I1 plus root I2 whole square. That equals to A1 plus A2 whole square. So this is the formula if they ask maximum intensities. And if in problem they mentioned both are same intensity, I1 equals to I, then the maximum intensity we can write I max is equals to 4 times of I naught. I max equals to 4 times of I naught. And if you go for the destructive interference, destructive interference we can write I max and V max that we call as A minimum. A minimum we can written as A1 minus A2. That I minimum we can write root I1 minus root I2 whole square, or else you can write A1 minus A2 whole square. A1 minus A2 whole square. Now, here in examination they ask I max by I minimum. This is very important formula. Very, very important formula. I max by I minimum 2 plus 2. Root I1 plus root I2 whole square by root I1 minus root I2 whole square. That is equals to, if they give intensities, we can use this formula. If they give amplitudes, we can write A1 plus A2 whole square by A1 minus A2 whole square. This is very, 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 very important formula. They can ask so many problems. We can provide in this case. Now, we discuss about fringe width applications. Fringe width. Very, very easy and important concept. Fringe with formula we have beta equals to lambda capital D by small d. Means fringe width is directly proportional to the wavelength. Fringe width is directly proportional to the wavelength. In ray optics, we know the colors entire here. This is violet, this is red. Wavelength of red color is greater than that of the wavelength of violet color. This is violet, this is red. We know red color having more wavelength than violet color. So if we use two colors, one is violet color, another one is red color, then beta red is greater than beta violet. The fringe width due to the beta color light, beta color, which beta means red color, is always greater than the fringe width due to the violet color light we can use. Okay. And similarly, we know the definition of wavelength of the medium. Wavelength of the medium formula we know. Wavelength in A by refractive index of medium. Refractive index of the medium. Yeah. Wavelength we can use. Now, that phenomenon we can use here. See, wavelength in medium equals to wavelength in A by refractive index. And we know beta is directly proportional to the wavelength. So from this we can write beta medium equals to beta A by refractive index we can use. Directly this is the shortcut form that we can use to find out fringe width. And suppose in problem they use in a certain way. If N1 fringes is there, N1 fringes are formed when wavelength is lambda 1. N2 fringes when the wavelength is lambda 2. Then what is the condition we can write is N1 lambda 1 equals to N2 lambda 2. If they gave wavelengths, we can use this formula. Suppose if they ask fringe widths, N1 beta 1 equals to N2 beta 2. N1 beta 1 equals to N2 beta 2. Okay. And the next one, they can ask the distance between nth bright and mth dark. And if they ask, what is the distance if they ask, we can write yn bright minus ym dark, that is equals to, you can write n beta minus 2m minus 1 by 2 times of beta. Suppose if they ask 10th bright and 7th dark, for example, then delta x is equals to, or delta y is equals to 10th dark bright means 10 beta, 6th dark means 6 preceding number, 7th dark means the preceding number of the 7 is 6. So we can write directly 6.5 times of beta. 10 minus 6.5. It is 3.5 times of beta will come. This is the way we can solve the problems here. Okay. Now, here one more thing. The maximum number of fringes they asked. Maximum number of others, maximum number of maximas. Maxima on screen they ask. So we have the formula d sine theta equals to n lambda. We have the formula d sine theta equals to n lambda. Now, so here we want maximum number means n equals to d sine theta by lambda. N equals to d sine theta lambda. The maximum value of sine theta. Maximum value of sine theta we know is equals to 1. Now, if we use that concept here, then it becomes d sine theta equals to n lambda, then n equals to d by lambda. D by lambda. We can write. So, this is the formula to find out number of maximas. This is one side. If the ask complete means we can write 2 n plus equal maximas equals to 2n plus 1. 2n plus 1. Okay? It is sine theta value should be less than or equals to 1. Okay? So next concept here they ask fringe visibility. Very, very important. In NEET examination, several times they ask this fringe visibility. Or we call it as band visibility. Right. So what's the formula for the band visibility or the fringe visibility means? V equals to I maximum minus I minimum by I maximum is I minimum. I maximum plus I minimum in denominator. First of all, we should know what is I maximum formula. I maximum formula we know root I1 plus I2 whole square. We have root I1 plus root I2 whole square. So this we can write I1 plus I2 plus 2 times of root I1 I2. I minimum is we have root I1 minus root I2 whole square. This we can write I1 plus I2 minus 2 times of root I1 I2. Okay, now if you take I maximum plus I minimum, so here I maxima and I minima, if you take difference, these two get cancelled becomes 4 times of root I1 I2. And denominator if you add, this if you add was these two get cancelled becomes 2 times of I1 plus I2. So this is the formula to find out fringe visibility. Very important formula. This is also. It has no units. Why? Because it's the ratio between these two. And this values always lies between 0 to 1. U equals to 1. When it is I minimum equals to 0 means V equals to 1. Okay? So this is the way we can write. Okay? So another one is missing redundancy. For missing wavelengths, the intensity of the light will be 0. Intensity will be 0. Means the path difference should be equal to 0 means. So we can write missing wavelength direct formula lambda equals to d square by 2n minus 1 into capital D. If you take n equals to 1, 2 means you will get the values lambda equals to d square by d. If you take 2, it becomes 3d, d square by 5d. Like all odd numbers will be missing here. Okay, so this is the way you can solve the problems from this chapter. And that's all for today's class. So we will discuss a few more things in the next class. Okay, thank you.